My name is戴禎慧. My advisor is Professor Lee, and today I'm going to talk about energy efficiency and glazing. Have you ever tried to lower the bill cost of electricity? Are you sometimes bothered by the high humidity in the house which makes you uncomfortable? Does it ever occur to you that the noise made by the neighbor interrupts your sweet dreams? An energy efficient house can help you solve the problems above. And today my topic is energy efficiency and glazing of a green building. About 1/5 of our national energy use is for climate conditioning. The climate here means the regulation of light, the temperature, or the humidity. And the energy is commonly needed for heating, air conditioning, humidifying, dehumidifying, and air cleaning. Since the cost of energy rises and the supply becomes lower and lower day by day, this makes energy efficiency more valuable. This picture is the energy balance in the summer. As we can see, the solar radiation, thermal conduction, and air infiltration cause a big amount of air conditioning. And next is the energy balance in the winter. The thermal conduction, radiative losses, and air infiltration is responsible for the heating system input. So no matter in the summer or the winter, there are still big amounts of energy input and energy output. So we should know how to block the heat flow to maintain our energy efficiency. As the plans are drawn up to the redesign or renew of the house, every decision that are made related to the window, the glazing, or the door can make a big difference. Proper consideration of the window is really important. Since we know that glazing affects the interior environment a lot, we should know how to make a good use of it. And here are a few types of glazing, such as floating glass, tinted glass, tempered and heat-treated glass, reflective glass, and spectrally selective glass. First, floating glass is a soda lime silica type. When struck, it will shatter into shock fragments, and it has poor performance under low temperature or rapid temperature change. So this type is the least desirable type. Next, tempered glass is used when floating glass is not strong enough. It has about 3 to 5 times the strength as floating glass. When struck, it will fall in rounded and very smooth pieces to avoid dangerous cuts. As to the heat-treated glass, it has the same strength as floating glass. Tinted glass is not a thin layer of film on the surface of glass. The tint consistent throughout the thickness of the glass. It can select some of the spectrum and absorb the solar heat, so it's better to reduce the light than reduce the heat. As we can see here, in the daytime, it's hard for us to see the inside from the outside, but during the night, it's easy for us to see the inside from the outside. Reflective glass is a thin metallic layer on the surface of glass. It has less solar energy transmittance, and it can reflect about 80% to 90% solar energy. As the same manner of reflection of mirror, it just looks like a mirror from the outside. Spectrally selective glass is best for buildings that have a long cooling season and which require high light level. It can block most of the UV lights and also the infrared radiation. However, it permits high transmittance of visible light. As we want to block the heat flow, we should know how the heat transfer. So, how the heat transfer? The heat transfer by conduction, radiation, and convection. And especially in this glazing case, there is another way called air infiltration. Conduction means a heat source applied to the one end of the conductor, and the thermal conduct through the material and emit to the other end. The heat is transferred by the particle, but without actual particle displacement. This means heat can transfer through the style, the glass, and also the rail. Radiation is a wave heat transferred by electromagnetic wave. It doesn't heat the air but heat whatever it strikes. Convection occurs when the warm air gives up heat to the cold glass. The cooled air sinks to the ground and created a draft within the house. The draft will be noticeable and uncomfortable. Infiltration means the full assembly of the door. The edge which against the wall and also the butts should be curved around because a smoky can cause a big amount of infiltration within hours. Some of the manufacturers, they send their product to an independent laboratory to prove that their product is made by specification of governments. And this specification is quantified by performance data. First, water resistance. Water resistance means the capability of penetration of water. It rating varies from 3 to 15 psi. And second, air infiltration. It varies from 0.1 to 0.2 cubic feet per minute. And the research shows wood frame is better than metal frame because metal contracts and is bent a lot. This table is the typical U factor for single and double glazing. U factor here means the rate of heat flow through a material. So the lower the U factor, the better the insulation. As we can see here, the standard U factor of glass. Double glazing is smaller than single glazing. And also here, unique U factor. Double glazing is also smaller than single glazing. This part, percent relative humidity when moisture formed at the center of glass. Single glazing is smaller than double glazing. This means single glazing is more easy to form a moisture in the center of the glass. This table is the typical heat gain for clear glazing. And it is obvious that single pane is bigger than double pane. This means single pane is easy to get the heat. As we can know above, the more layer of the glass, the better insulation. We call this kind of glass insulating glass. Insulating glass is made by 2 or more layers of glass with airspace between them. The edge will be sealed airtight. The glass is separated by airspace, by spacer, which look like this. First, metal spacer is commonly made by aluminum or stainless steel. Since the steel is the best conductor, it's easy to create a heat flow through the spacer. So we replace it with silicone rubber spacer, which has a better insulation. And what's more, we put the desiccant inside the spacer to absorb the moisture within the airspace. When the metal spacer is used, we put a thermal brick between the spacer to break the heat flow. Low-E coating is a microscopically metallic outside layer. It's transparently and it can reflect low wavelength radiation. The glass with low-E coating has low U factor, and it also permits natural light transmission. Low-E coating reflects infrared long wavelengths back into the house and also keep the solar heat out of the house. We divide the surface into 1 to 4. Surface 1 and surface 4 located on the outer glass. Surface 1 is the exterior face and surface 2 is the interior face. Surface 3 and surface 4 located on the inner glass. Surface 3 is the exterior face and surface 4 is the interior face. At the place need air conditioning, we put the low-E coating on surface 2 to keep the solar energy out of the house. At a place which need heating, we apply the low-E coating on surface 3. This can make the airspace absorb the solar energy and maintain the heat within the house. When we replace the airspace by inert gas, the energy efficiency will be greatly increased. The common inert gas we use is krypton and argon. They are both inexpensive and they are both efficient. Acoustical glass can absorb the sound wave, so it's better to reduce the noise than normal glass. We put the acoustic film between the glass, and the thicker of the film, the better the insulation. So let me jump to the conclusion. First, an energy efficient house can not only save your energy, but make your environment more comfortable. Second, make a good use of acoustic. Advanced glass can help your environment more energy efficiency. Being energy efficiency not only save your money, save your energy, but save the earth. Thanks for listening.
这个做的重